Students, today we'll start understanding quadrilaterals. Uh, this is a chapter where the geometry portion starts. Okay, so there's some of the things that you have to understand before we uh, get into the quadrilaterals world. Okay, now you see that we have come across with this particular word so many times in our life, isn't it? What is a plane surface? So if you just reback your life a little bit towards childhood, so you will see that there was a days when you were supposed to hold some crayons and all, and you were supposed to draw something on the walls or might be on a slate on a piece of paper. So the places where you were supposed to draw all this drawing, suppose wall or suppose slate or suppose one piece of paper, those were all were a type of plane surface. Suppose this is a paper where I've written all those things. This is also one example of a plane surface. Okay, so this is how we will begin the chapter, that is a quadrilateral. So the first thing that you have might be you have understood what is a plane surface. Okay, the place in if you consider that inside the classroom the teachers really explains you many things, that is where on the green board, isn't it, or blackboard. So that is also one of the example of plane surface. Fine, so let's come on, let's see what is there in a second point. So it is a dot. Fine, so this is a prominent dot and this prominent dot is called point. And always remember that this point is always considered with a capital letter. Fine, it could be A also, B also, but always should be represented by a capital letter. Fine, now let's, if I take 2 points, fine, 2 points, and join these 2 points with a line and name this as A and B. So this particular line is called line segment. So what is a line segment? It has two endpoints, that is a starting point and an ending point. Fine, so two endpoints, the line which is carrying a two endpoints, that is one starting point and one end point, is called a line segment. Now suppose if there would have been 3 points and the 3 points should be on the straight path, then what will happen? Then also there would be a one straight line, you see. But in this case, how many line segments is possible? 3, isn't it? That is AB, BC and AC. Fine, and these 3 points are called collinear points, students. So what is the collinear points then? The lines are the points which falls on a straight line, that is on a straight line. Now what if the lines are not collinear? Suppose if the points are not in the straight path but on the different position, suppose here, here and here, then what? In this case we can get one particular figure which is called a triangle. Fine, suppose like this, these are the points which are not on a straight path, isn't it? But when we join these 3 points we'll get a triangle. Fine, now see one very interesting thing about triangle. Suppose if you join two triangles like this. Okay, so what I've done is that if I join to this triangle, that is triangle plus triangle, if you join it like this geometrically, if you join it, then you see that you will get a figure that is of 4 sides, isn't it? That is of 4 sides, and this 4-sided figure is called quadrilateral. So quadrilateral is just nothing, it is a combination of two triangles. So okay, so what if there are 3 triangles? So when we join 3 triangles we get what? Another polygon, that is pentagon. That is, pentagon means 5 sides. Let's see, 1 2 3 4 5. See, so when we are when we join 3 triangles we are getting pentagon. When we join 4 triangles we'll get hexagon. Fine, so these are the figures are also called as polygons. So these are all types of polygons. Now how will you define polygon? So let us see. So it is a simple closed curve. So it is a closed curve. See, from every side it is closed. Fine, that is, the points are overlapping. Suppose if you have started from here, you have drawn a line, then again it is meeting at the same point. So these are the simple closed curve made up of line segment. Remember, circle is not a polygon because it is not made up of line segment. Though it is a simple closed curve, but it is not a polygon as because it is not made up of line segment. The figure, the two things, the two condition makes a polygon. That is, the first thing is it has to be closed, and the second thing that all it should be made up with line segments. So all the sides should be of line segments. Fine, so this is how we can define polygon. Now what we have observed here, what we have observed here, see, in a triangle, how many triangles are there? Only one. But in a quadrilateral, how many triangles are there? Two, isn't it? In a pentagon, how many triangles are there? One, two, and three, isn't it? So I've just made a chart. You just look at it because it is very important for your upcoming chapter also. So this is a chart, student. Okay. So triangle which is carrying a three sides, how many triangles it is carrying? One. Quadrilateral with four sides, how many triangles it is carrying? Two. It's the same way, pentagon, how many sides it is carrying? It's five. So five-sided triangle will have how many triangles? Three. Please remember this because you will find the importance of this when I will finish the introduction today. You will find these things is very, very important. Hexagon, it is a six-side figure. Fine. So it will carry how many triangles? Four triangles. So if you continue like this, you will find that the difference between the sides and the number of triangles will be of 2. The difference between number of sides and the number of triangles is 2. See, 4 side, 2 triangles. What is the difference? 4 minus 2 is what? 2. Pentagon, 5 sides. How many triangles? 3. What is the difference? 5 minus 3 is what? 2. Now let's see nonagon. Nonagon means 9-sided figure. So 9-sided figure will have how many triangles? 7. So what is the difference between number of sides and the number of triangles? That is 2. So it is a general thing. Fine. So this is the difference that you have to remember. That is number of sides, no matter what is the polygon. Okay. So if it is 100 polygon, suppose 100-sided figure. So if it is a 100-sided figure, so how many triangles it will have? 100 minus 2 is what? 98. So 98 triangles it will carry. Fine. So this is the logic that you have to apply.